Good evening, everyone, and welcome to our session on Hadoop High Availability demonstration. My name is Gurmukh, and I will be giving you a demonstration on how to set up Hadoop High Availability. So there are a lot of areas which we need to take care in production when we talk about high availability of a Hadoop cluster. Uh, but in today's session, we will be primarily focusing on the high availability of name node, and maybe in future sessions we will talk about high availability of a resource manager. So I will show you two ways in which high availability can be done if time permits, but at least we will do a demo of one way of doing high availability, and I will show you what are the ways we have. And during the presentation, all the participants will be on mute. They cannot speak, but they can ask questions in the question window which they have. So at any time, if they have any queries or any questions they want to ask, feel free to just type in your questions, and I will read that out uh, for the audience, and then I will I will answer that. So once again, good evening to everyone, and welcome to the session. So let me start quickly with a brief introduction about myself. My name is Gurmukh Singh, and mostly I am known by the name Aman because many people in the Western world they find it difficult to pronounce my name. So Aman is a more commonly known name, so you can call me by either of those two names. So I've been in this industry for more than 12 years, mainly into infrastructure side, working in different domains, right from field engineer to a Linux admin, an infrastructure engineer, and multiple multiple hats. And I've been into Hadoop for the last 4+ years, working with some of the big companies who had contributed to the success of Hadoop. And I'm also an author on one book which is already in the market, which is Monitoring Hadoop. And my second book is about to come in the market, which will be on Hadoop 2, Yarn, and its configurations, which we have not yet decided on the title of the book, but it will be out by February next year. So that's a little bit about myself. So let's get started, and I will show you what is high availability and how we can set it up. So the assumption during this session is like the people in the audience, they are already aware about what Hadoop is. They might have at least seen it or used it in maybe in a lab environment, and they are familiar with the basic things like what is a name node and what kind of challenges we can have if a name node goes down, those kind of things. So in this session I will not be talking about anything in terms of okay, what is a name node, what is a metadata. So here our topic will be mainly concerned with how to make a name node highly available. So let me see if we have any questions till now. Okay, so let's get started. So in Hadoop, uh, name node is a very critical point, and it is a single point of failure. And when I say it's a very critical component, it what does it mean? It is the main node in your cluster which takes care of your metadata. So if your metadata is gone, you cannot access the blocks on your cluster. So your data is gone, or at least we will have a downtime. Uh, right, in a enterprise production environment, let's say even if I am not running highly available name node architecture, I will be having some mechanisms in place, like having a rate for my name node, or I will be having a name node set up on a hardware which is redundant in terms of, like, let's say the power supplies, the multiple network cards. So there will always be some redundancy built into it. I will not, there will be very few chances of losing your data, but yes, the chances of name node going down will be quite probable, and there will be chances of causing an outage. So we will be looking at how we can make a name node highly available and how we can quickly do the switch over. And I will be discussing about two techniques which is used in the enterprise or in the industry today. One is the kind of a manual failover mechanism, and other is the automatic failover. So let's look at these two ways. So let me give you a quick recap of how the name node is keeping track of metadata, and what are the critical locations we have in name node where the data is actually stored. So let me just give you a simple drawing. So let's say I have a name node. I will donate it by NN, and let's say on this name node I will be having a location. Location means I will define a mount point on my file system where I will be saying that all the metadata for my name node will be written. Let's say in your name node you will have two kind of files. One is FS image and other will be your edits. So these two files will be written to a particular location. So this location in our recent versions of Hadoop is defined by a parameter dfs dot name node dot name dot dir. This is the parameter, right? So in the old times this parameter used to be dfs dot name dot dir, but the parameters keeps on changing over a period of time, but now this has been stable in Hadoop 2. So this is the parameter in the config file which tells, okay, what should be the location where name node should be flushing the contents of its memory. So we will say, okay, this is the location. So in this location I may say, let's say slash data slash name node. I have a directory which is a mount point. I'm saying flush everything there. So I can have multiple directories under this field. I can give a list of comma separated fields. I can give 2, I can give 5, I can give 10. But the problem will be if my listing is too long, name node will have to commit to all those locations, and it will take a lot of time for the name node to do writes to the disk. So we will not go more than 2 locations in this field. So one location will be your local disk, second location will be something outside your system like an NFS mount. So presuming like people are aware about what NFS is, let's say I will have an NFS server. Let's say this is my NFS server. So when I say NFS server, it could be a simple Linux box which is running your NFS server, and it's presenting some disk. Let's say it has some disk and it is presenting that disk to name node, or it could be a filer, let's say a NetApp filer. The main thing is it's just running a simple NFS service, and that disk location you can mount on a name node. So on name node, I will have two critical locations. One within the name node, which will be on the local disks within the name node. I will be saying some one location, and other location I will be saying coming from some external location. So let me show you on the system first. What does it mean? So in my clusters have multiple nodes, but for the sake of understanding and keeping things simple, I'll be using about two nodes for high availability of name node and two data nodes for the demo. So let me show you what I mean by this. So I'm sitting on a node currently named nn1.cluster1.com. So when I say nn1, it means name node. I've given a naming convention like that so that it is easy to follow up by just looking at the name what the node is. So if I resolve this, like it gives me an IP, right? This is all standard setup. So our talk is only about high availability. So your resolution is in place, everything like your Linux part is set up, like you should be aware about what will be your IPs, how you will be setting up DNS, and you if you want to enable firewall, what ports to open, all those things will be in place. So first thing is I should be having a Java installed, like this is standard whenever you are running Hadoop name node, you need a Java minimum Java JDK version 1.6, and you should have set up any distro of Hadoop or any version of Hadoop. So I'm currently using Apache Hadoop. So because I use always Apache Hadoop for demonstrations, because uh, it gives you the right kind of a picture. Like if I go for Cloudera or Hortonworks, you can do everything from the graphical UI. Let's say by using Ambari or Cloudera Manager, so it hides a lot of intricacies and the details what goes at the backend. So the best way to learn is by Apache Hadoop way. Take tarball from Apache Hadoop. So currently I'm sitting in a directory. Let me show you. Let me go to my home directory. I'm running, I've created a simple user Hadoop. I'm logged in as that user. So whenever we create any service, we will not run that by user Hadoop. We will always run it by a non-privileged user. So this is, I assume everybody will be aware of, whether it's an Apache web server or MySQL server or even in Hadoop. So you will be creating any user and running Hadoop by that particular user rather than running it by root. So I have the option, either I can set up Hadoop in my home directory, in the home directory of the user, or you can have a common location, let's say /user or /opt, right? So you can follow any convention, naming convention. So in OPT cluster, I have already untarred a Hadoop tarball, Hadoop 2.6.0. So I will be, as I said, I am making an assumption that you guys are aware about what Hadoop is and how you set up a basic Hadoop cluster. So I will be mostly talking about only high availability. So let's say I go to the directory where we have the Hadoop tarballs. So let me show you what I was explaining you. So if I open my Hadoop uh, in Hadoop, my core-site file, you will see a property like this. So this property will tell me where is the name node. So in my case, it is telling, okay, nn1.cluster1.com on this particular port, I have a name node service, and 9000 is the RPC port on which I can fire the commands. Second is htfs-site. Let me open this file for you. So this file, if you look at, so this is the property I was explaining you. So this parameter is the one which is defining where name node should write its metadata. So I can give this to be multi-field value. I can give high comma, and I can give here any directory. Let's say file colon data slash x, right? So I will give it multiple locations for redundancy, so that I'm writing saving metadata at multiple location. So I can give this location to be some NFS mounted location also. Means I have an NFS export coming from my server, and I'm giving it as a location here. So whenever I format my name node, it will create a file system on both the locations. But let's start with the high availability part. So if I open my core-site file, if we are not running high availability, we talk in terms of specific name node. If you look into the core-site file, there will be a parameter which will be fs dot default fs, which is saying file system default, what will be default for my name node. So this is what is defining where my name node will be running. This is fine if we have independent nodes, like when I'm not running high availability, then I can say specifically my name node is on NN1. But what if I'm running high availability? So let me SSH to another node, and I have another node which is I have set up as name node 2. So let me just see whether it has come up or not. Okay, I just changed the interface of that. Okay, so that has come up. So here, let me increase the font. So this is my second node. If I do hostname here, this is my second node. So let me change as user Hadoop, and let me go to that directory. So directory location could be anything, whatever you might have set up. So if I open the file here, vi core-site, let's say if I'm on N1, I can say n1.cluster1.com. If I'm on N2, I can say n2.cluster.com. And both these name nodes will run independent of each other. But when we talk of high availability, we have to configure a common string which will say which is the name service we are making highly available. So what does it mean? By default, if you have only one name node, I am specifically targeting that name node by an FQDN, means fully qualified domain name, like nn1 dot cluster1.com. I'm specifically targeting by that name. And if I bring one more node, let's say nn2, and if I give it a separate name, nn2.cluster1.com, then when my data nodes connect, they will connect to whether they connect to nn1 or they connect to nn2. They can only connect to one. So I cannot have high availability because these two name nodes, they are not talking on a common name service point. So first of all, what I have to do is I have to get rid of this thing. I will not be running name node on any particular FQDN. I will run on a common string, any string you like. So let's first change that. So whatever I will be talking to you in the in this session, everything is available in my GitHub. This is a public GitHub I maintain, so anybody can access it. Let me give you the link in the chat. I've done a broadcast to all the audience, so they can make a note of this GitHub. So they can refer this GitHub. It's a public GitHub. I have not put up any password to this. So anything you need in Hadoop, you can get it from here. And these are not just hit and trial. These are actually from running cluster, these configurations. And I have drilled down those configurations so that they are easy to be understood by beginners, right? But you will find category for each. So for example, we are today talking about high availability. So you will click on this HA underscore Hadoop directory, and you can pick up the configurations from here directly, right? Copy paste. You don't need to remember anything. So the first thing is this. This is what I was talking about. So what I have to do is, first in the name node, I have to get rid of this property, and I have to put a property like this. Now I am not saying my name node 1 or name node 2. I'm just giving a string. This string could be anything. I can put my name, any string, but that string will be unique. You cannot change that string afterwards unless you reformat it. So once you keep that string, it will be throughout the life of the cluster. Save it. I will open htfs-site. These two things remain same. So what we have to do now, let's go back to the slide. So there are two ways of achieving high availability. One is by using a shared NFS location, and second is by using Zookeeper quorum, right? So I will try to demonstrate both, taking time into consideration, but definitely we will talk at least one in detail. So as I was explaining here, the name node is writing the metadata to a directory, which is defined by the parameter dfs.namenode.name.dir. But this parameter is just visible to that particular name node. Let's say I have name node 1. Let me explain you on the board. Let's say I have a name node 1, and inside that name node there's some hard drive, and on that hard drive I have, let's say, a location where I'm writing my metadata. So this location is visible only to one particular name node, nn1. Let's say I have another name node which has a disk in that, and this will be available only to nn2, right? So instead of this, what we do, we create a common location, a shared location using NFS, and we will mount that on both nodes. Rather than using a local disk storage on each of the name node, we take a slice from a filer or a Linux NFS server and mount on both the locations. And that way we are sharing the metadata between two nodes. Because if we don't do that, let's say I was running nn1, metadata was here. When the failover happens to nn2, this metadata, how we will sync it, right? We cannot guarantee this metadata is same. But if we keep a common location, both name nodes are reading from the same location, we will have this consistency. But the challenge here will be how we will take care of locking. I cannot corrupt certain data here if both nodes write. So how we safeguard is, only one will be active at a time, other will be standby. So the node which is active will be the one which will be doing writes. Only the active node can write. Read can be done by both the nodes, right? So this is one of the very fundamental ways of doing high availability in Hadoop. So what we say is I take one name node, mark it active. Second name node, I mark it standby. Both nodes can read data from NFS, but only the active one can write. And data nodes now talk to both. Initially, in single name node, data node were knowing only about one particular node. Why? As I said, in core-site, we were just giving the name of one particular name node. But now we will be giving a string name. And that string will be not specific to a name, but it will be specific to a name service, which will have mapping for both the name nodes. How we will do, we will see that. So now the data nodes, they talk to both. And whichever is active will be serving the requests. If this node goes down, this can become active, and it's a switch. So this is different from the secondary architecture. In secondary, if you remember, or if you have come across, if you are from production background, I have a name node which is my primary name node, and I have another node which I have configured as a secondary name node, which is going to my name node and doing checkpointing occasionally, uh, right, periodically. In that case, my data nodes, they only talk to my primary. They never go to and talk to secondary. But in the case of HA, they talk to both. Data nodes are aware of both the nodes, and they will be aware which is the active. So they will be going for writes or updates only to the active, taking commands only from the active, whichever of the node is active. But they will be sending block reports to both. They will be aware of that. Okay, so now let's go back. I've set up core-site. Now I will open HDFS-site. So now other thing I have to define here is that shared location, the shared NFS location which I was talking about, I have to define that. So let's pick up a configuration from HDFS-site. You can give that location any name. I will show you what name I have given. So what I will do here is I have given a mount point. So now what I'm saying is which is the shared location directory where my metadata will be shared. This location can be anything. I can keep it as shared example, right? So what I will do here is, if you look at my server, I have a mount point which is coming as an NFS. If I give command mount-t or simply mount, you will see there's an entry like this. So this is coming from my server, which is running at IP 254. It is presenting an NFS mount, which I have mounted here on my local disk by using command. This is all Linux stuff. Same I have done on my other node as well, name node. right, which I have done here as well. And you can look, if I show you the permissions of this, it's currently empty, directory is empty, and the permission is it's owned by user Hadoop. And if I go to my server, this is my server which is presenting it. On this, I have a service running. Oh, okay. So I'm running it on a 7. So if you look at ps-ef pipe grep NFS, right? So I'm running an NFS service here, and you can see export fs-v, and I'm presenting this from here, right? So this is all Linux. So I am mounting that vi hdfs-site. I'm opening that. I'm creating that location. Any name you can give. Now, the second thing which comes into picture is I will be now defining the name services. Let's go a little bit down here. I will take property one by one. So I'm right now saying the name services. This name will be same as what I have given in my core-site. Right? Whatever name you have given there, you will be keeping that. So this string is identifying my service. And now we have to define what are the members of this service. I'm saying NN1, NN2. This can be any name, right? This can be any name. I can say X comma Y. These are just kind of aliases. So when I will execute a command, rather than writing, uh, let's say a command on nn1.cluster1.com, that long name, I can simply say nn1. So it's an alias which I'm setting. I can set simply X comma Y. It has nothing to do, don't think that it has to do with the name of my system, nn1, nn2. No, it has nothing to do with that, right? It will be more clear. Just bear with me for a second. If you look at this property will be defining what that nn1 is. See, so I'm saying this name services whose name is identified by my cluster has two members, nn1 and nn2. nn1 is which node? nn1.cluster1.com. I could have written X here and then I would have replaced X here. Similarly, I will say which is nn2 here. I'll copy this. I can simply paste it here. I can say which is nn2. I will change this to nn2. So it's identifying that short name is identifying the complete name for me. I can give that any name. Now, after this, what I have to do is I have to define the web servers of both the name nodes, because why? Even if in secondary name node, if you have done a practical on that or have set up those, the data transfer always happens using JT web servers, which is built into each of the daemons. Let's say you have to copy a block or do a data transfer. Data transfer always happens by opening an HTTP connection. Commands go by RPC channel, right? So you always, that's why each daemon in Hadoop will have a web server running. If you shut down the web server, you will not be able to fetch data or deliver data. So there are two command channels, RPC and HTTP, right? Again, that's a different vast topic, but we will be only talking about here. Our talk will be limited to high availability. So here, what I'm saying is NN1, on which port my NN1 is running the web server. Same thing I will copy. Same thing I will put for NN2. I will say which port. Let me correct the name here. My node names are cluster.com domain, and I am simply saying these two domains. Now I have set up web servers so that two name nodes, they can fetch the data across each other. They can fetch the data across each other. Edits they can anyway pull from the shared location. But what about the FS image? Right? There are two metadatas, FS image and edits. So edits, whatever changes we are doing, it is going to that shared location which we have configured, filer one. But the FS image, which is a read-only copy, which get merged by checkpointing, that will be transferred through these two web servers. That's why we have to need to have this property in place. Then we need to define the proxy failover provider class. This is a class which handles the failover mechanism and also lets the data node know which is the active node. For example, when data node broadcast and they connect to a name node 1, name node 1 will say I am active, or name node 2 will say I am passive. So all this is defined in this proxy provider class. Also the switchover happens, the mechanism of switchover is defined in this proxy provider class. So we have to have this. So after that, this, it is my wish, I don't need to configure anything else. But when we are switching from name node 1 to name node 2, let's say I'm sitting on name node 1 and name node 1 is active, and I switch name node 1 to be passive and I make name node 2 to be active. So in that case, these two nodes should be able to fire commands across each other without being prompted for password. Similar to how we do passphrase SSH, right? We set up our private and a public key, SSH key. So they will be able to execute commands across each other without being prompted for password, right? So this is optional. Whenever I will fire a command, it will prompt me for password otherwise, right? So it's your wish, but better to put it. So I will put this here. So this can also be used to define a fencing mechanism. Means I can configure a script, like for example, for test I have given only bin/true, but I can say whenever this class is called, execute some command here. What command it could be? I could be shutting down name node service here. I can call a script which runs and calls for the shutdown of the daemon on this node, right? I can customize it, but as I said, this is optional. So I will save it. Same thing, instead of writing again, I will copy directly from that node. So I will copy scp core-site. I will copy to the other name node. So you can see there's a passphrase less access setup between these two nodes. This is again all Linux stuff, like you are going between nodes without being prompted for password. So I'm just copying that core-site file across, and then I'm copying htfs-site across so that I don't have to type the same things again. So now both nodes will have the same configurations. NN1, NN2. This is my NN2. NS lookup, NN2. Okay, so question from Priyanshu is, what's the guarantee that shared name node filer will not fail? Okay. See, so that's why I said we will use a enterprise grade filer, let's say from NetApp. So the filer itself will have high availability. It will have a multiple channel path, like similar to multipathing how we do, and it will have redundant controllers sitting on that filer, and they will be presenting a rated array of disk, right? We called it as LUN, which is logical unit number. So what it will do is, instead of presenting the entire one that shared location from one disk, what it will do, it will stripe it across multiple disks and present it from there, so that even if few disks fail, it will affect my performance, but it will not cause an outage, right? But yes, what if the network connectivity between my filer and my host goes down, right? Then that case, it will be a problem, but I'm always making a local copy as well, right? I'm always making a local copy as well. Okay, now these two things are set up. So all this is available in the config file. So now I have to go to data nodes now, right? So let me go to any of my data node here. Data nodes are running on 72 and 73. So I'm going to data node vi core hyphen site. So same logic comes here. Initially my data node was pointing to one name node. I cannot do this now, because name node will go to one node, and if failover happens, it doesn't know where to go. So I will remove this property, and I will replace this property with that string. So string will be that my cluster string, whatever you have chosen. So I will put this here, dfs.name.services. So this parameter will be same as what we have in core, because core file remains same throughout our cluster, right? Same thing. So I will be copying this here, and I'm saving it. vi hdfs hyphen site. So in this cluster, you will look, you see that I have data node which has 3 hard drives. Let me save it and show you. If I do df-h, you will see there are 3 hard drives mounted in each data node, and data nodes are writing data blocks there, right? This is not metadata. We are doing high availability for metadata. There was high availability always for data blocks, because we are replicating it 3 times by default, right? But name node high availability was not there from day one. It came from Hadoop 2 only. So now this is the property for data node, where we are saying multiple disks for your data node, right? So when I say highly available by having replication 3, so it does not mean that they are replicating blocks within a data node, because I have 3 disks. So it does not mean, let's say I have a replication 3, so it will, one copy will go to each disk. Replication is always across nodes, different nodes, irrespective of the number of disks I have. Whether I have one disk here or I have 10 disks in a data node, there will be only one block on one data node. The second copy of that block will always go to another data node. So now I will have the same mechanism here, where I will be only talking about the RPC service and the proxy provider service. So I can, if you want, you can copy it from here. What all I need? I need only the RPC addresses and this property. So again, I'm telling here that what are the two name nodes members and what is their addresses, and I have to also tell the my cluster. What is my cluster? I have not defined here, so I have to put this parameter also. So you don't worry about configurations, you can take directly everything from GitHub. I'm explaining you the concept. So now this is in place, and now you have to tell the proxy failover class as well, because data node will otherwise not know which is the active name node. So I will take this and I will put it here. Now I will save this file. I can copy this file one is core-site to the other data node dot 1.73 opt cluster Hadoop etc. I'll copy it here, and the other file which is htfs-site. Two files I will copy. Right, so now I'm ready with two data nodes and two name nodes which are master. So now how we start now? So let me show you on data node. First of all, we do not have any data. All these directories are empty. All mount points are empty. On name node, let me go to name node 1, ls-l/data/name node. Right, so I can empty this because I think I might have run a format initially. Right, so I do not have any data, so it's blank. ls-l shared is also blank. So the first thing we have to do is, it's your choice, you can choose either name node 1 or name node 2. Which is the node you want to format? We will format only one node. Why we will not format both? Because the moment we execute this name node format command, Hadoop or HDFS name node, I execute format, I hit enter. See, first of all, we will check here. See, it is aware of shared and data node. So it has successfully formatted both. So now if I show you, you will see current directory has come here, and under the name node also there is a current directory which has come out under. Both will have version file. Let me cat it that for you. So whenever we execute the format command, it creates a namespace ID. So it has given a namespace ID 130 some number. This is a random number. This will be unique throughout the life of the cluster. What does it mean? I will never execute the format command again. So if I execute the format command again, this number will change and my nodes will not be able to join. Data nodes will not be able to join. I can do this on a new cluster. But once I put my cluster into production, my data nodes start communicating. I cannot change this number. Now, if I go to name node and again execute a format command, it will again give it a namespace ID with some other random number, because this is a randomly generated number. We have a mechanism of providing an exact number, right? All those comes into a different advanced topic. While doing a format command, I can also give my namespace and a cluster ID, what it should specifically be. But I'm showing you there's no need to do that. So if I simply go and execute our name node format command here, it will create the same structure there, but with a different ID. I do not want that. So it's your choice. Choose either of the node. Execute format command only on one node. Once the format is done, go to the other node. Here you will see data. It's blank. Let me delete this. The name node directory on second name node and then 2 is blank. On name node 1, it has been populated because we executed the format. I cannot execute format here because otherwise it will generate another unique version ID and cluster ID, and they will not talk to each other if cluster IDs are different. So there are two options I have now. One is either I manually copy the contents of this. I simply copy this current directory and put it here. One option. Second option is I go here and I say to this node, you go to name node 1 and fetch the metadata by yourself. Right? So there are two options. Either I manually copy it, this one, to the second node, or I say to the second node that you go and you fetch the data. So you can do that by simply executing the bootstrap standby command. What I will do on the standby node or on the second node, I will say you bootstrap. Bootstrap is what is the meaning of bootstrap? You are, when the system boots or any service boots, it boots up with some pre-configured parameters and some pre-configured configurations. So here when I say execute this command, I hit enter, it will look into its configs, and from that config it will come to know which is my other name node. It will come to know which is my other name node. Okay, one step we forgot here. We did not restart, we did not start the service here. We have although formatted, but we have not started the service. So I will say Hadoop daemon .sh start name node. So let's check whether service has started. I will check it. Let it stabilize. Right? We should not rush. Let it stabilize to make sure this daemon doesn't die. Always get into a habit of reading logs, because logs will give you a very clear picture what's going on. If is there something wrong, it's good to catch that at the very beginning. Let's see, anything unusual we see in the logs. It's saying starting will roll logs on active. Okay, fine, this is fine. So my name node is active. So now I do Hadoop fs-ls. You can see my first node. When I start the service, I execute fs there. What will happen is currently no node, although I have started the service, is active. Right? So how will I know which node is active? HDFS HA admin, if I do and hit enter, HA admin, and I can get here check service status. So if you remember the small shorthand name we are given, that is the name we are using here. If I would have given X, I would have used X here. I hit enter. It is standby. So that's why that ls command was not getting executed, because I have started the service, but this node is also standby. Now we execute the command here. We will not activate before both nodes come up. Why? If I activate this movement and people's data nodes start writing and you start using your cluster, there might be corruption. So your cluster, both nodes should be up and ready before we do that. Now see that it automatically formatted means it automatically went to the other node and pulled that file for me. Data name node, and you can see current. I can show you the version. Both will be same. They have to be same number what we have on the other side, same number. Look at the cluster ID. This will also be same, because both nodes are part of the same cluster. Now I will start service here also. Start name node. Okay, both are up now. Now I can execute the same command here to check the status. Any node, doesn't matter. If I execute here, I can do nn2. I can do the same thing here. So when my cluster came up, both my nodes are standby. So it is now my choice which node I want to make active the very first time. I can transition any node to be active. So I don't need to remember, as I said, any command. I can simply hit enter and it will tell me command. So I can transition a node to active. I can transition a node to standby. So currently my node, let's say NN1, is already in standby. So I have to transition it to active. I cannot transition to standby because it is already in standby. So I say transition to active, which node? NN1. I can do NN2 also sitting on this node. I will show you that, but let's start with NN1. So let's see what is my status now. NN2 is still standby, but NN1 is now active. Now I can do Hadoop fs-ls. Now I am seeing data. Data means metadata. Now I have to start my data nodes. Hadoop daemon.sh start data node. So I'm doing one by one just for the sake of understanding, but in production we will be executing a start DFS and it will start all your daemons in one go. Right. This one, and let me go to another node. 70, which was the IP? If config is 72, okay, this is 73. Go there, and also I do a start of data node there. ls-l, let me show you, we don't have any data there. I do a start here. It goes, looks for using that proxy failover controller. It looks which is my active node, active name node, goes, registers with that, fetches all the details from there. See, it fetched all the information. Now let's copy some data. vi test underscore file. This is a test file. I copy this. Hadoop fs hyphen put test file to hdfs. See, if you forget to give one thing, I will tell you what errors commonly people make here. If I forget to give this line on the in the data node side, data node will come up this, right? If you see in the service, data node will be running. But when you try to do a copy command, it will throw you an error, cannot find data node, cannot write to a data node. If I do not give this failover proxy provider in data nodes. So now it has done that. So what I can do is I can do failover. I can play around. Get state and then one. I can transition from one name node to the other name node. Now one is active, one is standby. I can do a failover now. I can do a failover. Failover from what? NN1 to NN2. I'm saying failover from NN1 to NN2. Failover successful. Now if I do get service, NN1 has become standby, NN2 has become active now. I again look for that data which I copied. Data will be there. So this is a high availability, but still this is kind of a manual because I have to go and execute this command. When I say I have to go and execute, doesn't mean necessarily I have to physically sit and execute. I can write a script which will monitor for the presence of health checks and daemon running and automatically fire a command. But still, this is a manual process. There's a second way of also doing by a zookeeper mechanism in which it automatically checks for the health of the services, and without any human intervention we don't have to execute these commands also. It will check which is the active and what is in good state, and it will keep on transitioning between those nodes, right? So this is what we have in this. So this is very basic way of setting name node high availability. There's a second way of also, which is zookeeper. Okay, we have already at 1 hour, so maybe probably whenever we do a next session I will show you how to do high availability by using zookeeper, in which you will be setting multiple components. For example, you will be setting a zookeeper quorum, then you will be setting up a journal node as well, and then you will be doing a fencing mechanism which is called zookeeper failover controller mechanism, and that will automatically control your failover mechanisms. So any questions you have, feel free to ask, or you can reach me out after the course as well, or after this session as well. So I have a YouTube channel, so you can follow this. I keep on uploading videos there. You can reach me there, or you can follow my GitHub. So in this GitHub I have given my contacts. You can use these emails to reach out to me with any questions you have, right? It might not be directly related to what sessions we did. It can be anything in Hadoop or big data domain or anything, and feel free to use whatever you want. You can go one level up as well. So I have other repos also. There are few which I have forked from other, means I am not the owner of that. I'm owner of currently this Hadoop one. I'm the owner of DevOps, and a few more. One is on C, so, and one is on Python. So you can use any of these, but I am the author of these two, Hadoop and DevOps. Okay, guys. So thanks very much for your time. I hope this session was useful to you. And please feel free to reach out to me with any questions you have. And probably see you in the next session, maybe 1 month down the line, or I will keep you updated. And if anybody is looking for any specific session, then let me know. We can plan accordingly, and I can give a session on that. Okay, guys. So thanks for your time. Have a nice day. I think it's probably now we are hitting night time in India. So good night, and thanks very much for your time. Bye bye.